Well, welcome to this particular training class. This is a little bit different than what we had been done over the past year because this time we're focusing more on passenger car stuff. It's our passenger car motor oil and oils update. We've really got it divided into three categories here that we're going to talk about, specifically the engine oil itself. We'll talk a little bit about the product's background and kind of some of the new features, what's coming new with engine oils. The next section on light-duty trucks is mostly to discuss, and if you do not already know about the relatively new diesel oil engine classification, this is going to be important because it's rolling its way into the light truck world. And then on automatic transmission fluids, we're going to talk about the newer technologies in transmissions, and we're going to talk a little bit more about product specifications and automatic transmission fluids. A lot of confusion can be had out there. Hopefully you'll get at least some guidelines on getting this stuff squared away. Okay, so we're starting in with engine oil, the passenger car motor oil segment. And we're going to talk, as we usually do, about the formula, how you make a passenger car motor oil. Pretty straightforward stuff. A motor oil is a base stock plus some additives. A base stock is the wet and slippery stuff. That's the body of the stuff. The additives are things we put in, usually to enhance some property of the oil, sometimes to stop it from doing something we don't want it to do. It's a pretty basic formula. This is true of motor oil. This is also true of ATF. Use a base stock and an additive. And we're not going to go taking a deep dive into additives or into base stocks, at least not in this session, but we'll take a little shallow dive into each of those real quickly. On the base oil side of things, there are a couple different kinds of base stocks that can be used. Mineral oil, that's your typical oil that came out of a refinery, came out of the ground, got cleaned up and straightened up and got the right viscosity chosen. That's mineral oil, been around a long time, right? Used everywhere. You can also make oils out of synthetics, okay? So you can have a synthetic-based motor oil, right? Kind of makes sense. Synthetics give us some special properties, but mostly they last longer. That's their biggest thing. They live longer than a mineral oil. Now, that would be simple enough, so we have to complicate things a little when it comes to synthetics to find out that there are two kinds of synthetics used in engine oils. There are the group 3 synthetics, and group 3 synthetics are the vast majority of the type of synthetic that's used in engine oils. The other kind of synthetic that's used is called a PAO, sometimes called an SHC, but most commonly known as PAO, which is short for a very, very long word. PAOs are found in some motor oils, but they're more rare. The classic example of the PAO base stock in an engine oil would be Mobil 1 full synthetic. But most of the other full synthetics out there are the group 3. Does it matter? Well, maybe and maybe not. On a lab basis, you have to work to see the difference between the two synthetics. Okay? They are chemically different, but on the lab basis and on test benches, you really have to work to tell the difference. But group 3 synthetics are much less expensive than the PAO types. That's why they're the ones that are used in the majority of synthetic engine oils. Yes, Rich?
They both still get dirty when you use them.
That's very true. And they get dirty at the same rate when you use them. Yep. The third thing that's pretty common out there are blends, right? Synthetic blends. Sometimes called parasynthetic, sometimes called semi-synthetic, sometimes just called synthetic blend. Probably the most important thing to know about synthetic blends is there's not an industry standard for how much synthetic has to be in a synthetic blend. Okay? It can be 50%, it can be 60%, it can be 10%. You will find there are people out there who play games saying, well, you know, those additives we put in, those are all synthesized, so since you have synthetic stuff in your oil, it must be a synthetic blend, even though they don't have any synthetic base stock in it. So if you're going to buy a synthetic blend, buy from a reputable supplier. All right, and that's about all I got to say about base oils. We will go on to the additives, passenger car motor oil, and ATF, one of the more highly additized oils that we sell. Got a bunch of stuff in it to do a bunch of different things. And we could put on a day-long session just going one by one through each of these additives and what they do for you and how they work and that sort of thing. We all know detergents are in there to help keep engines clean. The viscosity index improvers give us our multi-grade functionality, 10W30 abilities. Anti-wear agents, this is the zinc stuff that's in there, right? Helping prevent metal-to-metal wear problems in an engine. All the way up and down, all these things have value and are put in there. And within each of these, there are usually at least two and sometimes more technological approaches for how you do it. There's 3 or 4 different types of viscosity index improvers. Okay, there's half dozen different kinds of detergents. There's at least 3 different kinds of anti-wear agents that can be used. And that's why different companies have different engine oil formulations. That's why not all engine oils are the same, because depending on which of these you've chosen, some function better in some ways, some function better than others. Some of them are just dirt cheap compared to the others. You can find viscosity index improvers that are really great and some that are really, really cheap. And in the world of additives, this viscosity index improvers, the stuff that gives you multi-grade, that's a good example of a get what you pay for on the formulation side. Okay, so these are some of the things that make a difference in the different oils that are available in the market. All right, and that's all I'm going to hammer on the additive side of things here. I want to talk a little bit now about the quality of engine oils, the quality levels, and how the quality is determined or measured. And again, that's another day-long course, right? Going through all the various engine tests and approvals, and everybody would catch up on a lot of sleep if I spent time doing that. So we're just going to talk on the really basics of quality levels of passenger car engine oils. Okay? By and large, when you come to the quality level that you're looking for a car in the U.S., it's defined by 3 organizations, or 3 organizations may or may not be involved in the quality description. It might be on the data sheet or the recommended in the owner's manual. Okay, the first one is the API. Okay, the API is the American Petroleum Institute. Okay, it's been around the API has been around since 1919, and it does lots of stuff other than just engine oil quality. That's just one corner of their business. The API has a whole bunch of specifications on the products used to drill holes in the ground to get oil out. Okay, it's a very large organization. The quality of motor oil is only part of what they do. They really only affect the North American market, and they are led by the people active in it and that are fully members, are members of oil companies. Okay, all the oil companies that are involved in formulating engine oils. So for years and years, the API has been involved, was the leader in determining this is what a quality engine oil is. And I've got a chart on that in a few slides to show you how that worked. Okay. The second organization that's involved in it these days is called the ILSAC. Okay. I can't even remember what the acronym is, International Lubricant Specifications and something Council, something like that. The ILSAC, again, only applies to the North American market, okay? But instead of the API, which is oil company stuff, the ILSAC is run by this consortium of Japanese and U.S. automakers, okay? The engineers, the lubrication engineers from the American auto companies, the Japanese auto companies come together and pull together the specifications that they want the oil to meet that's going to be used in their engines. All right, and I'll get back to how they came about in a couple more slides as well. And then the third group that gets involved in specifying the oil quality in vehicles that you may see in the U.S. is the ACEA. Okay? The ACEA is the Eurozone, the European auto manufacturers, and their specification levels. Okay? So they're all European OEMs, and they get together. So if you go through the manual of your Mercedes-Benz or something like that, there'll be an ACEA requirement in one of their listings. And I have a slide on what their products are, but I'm not going to spend a whole lot of time talking about the European ones. But they have their own levels that somewhat parallel, but not exactly what's being done in North America. Okay, so going back to what the API has, the API service classifications is how they determine quality. It's called the API service classification. Largely shown in this, their trademarked donut, what the service classification is. This is the service classification SN plus being shown here, which is the most recent. And this is the timeline of the service classifications since the API has been involved with it. SA was not much more than just a straight mineral oil, hardly any additives in it. And in 1920, they didn't think about putting much in the way of additives in cars. They hardly had any. SB had a little bit more. And you can see it marches its way through time, right? These oils are getting progressively better year by year. The API would get together, and the way this worked, the API would get together with the auto companies and talk to them and find out kind of what was needed, and then the API would go back and come up with a specification to meet what the car companies had been talking about. And so things march their way on, improvement, up to we are now 2018, they introduced SN plus as an improvement, a slight improvement over SN, which goes back all the way to 2011. Okay, so this is the progression of quality level in motor oils as determined by the API. The ILSAC classifications are maybe a little even less cleverly named, GF1, starting at GF1, up now through GF5. GF5, again, at 2011. Each one of these corresponded to an API service level starting at SH. And kind of what had happened here, the backstory, is that I mentioned how the API kind of was leading this whole thing. They were the oil companies. They were deciding the specs. Well, the Japanese and American car makers said, you guys aren't making good enough specs. We're turning out cars that are improving in quality so much, and you just can't keep up. Your oil's not keeping up. You're not getting them to market fast enough, meeting the things that we really need to have going on inside these engines. So they got their own group together to specify these things, and now they'll specify they'll still work with the API to come up with their GF requirement, and then the API kind of goes over and scrambles to create a new service classification that will meet the GF classification, okay? I mean, and if you thought things worked slow before in the world of API classifications and improvements, this doesn't really speed up the process, but it did give some sense of urgency to the API to hurry up. And really the ILSAC, the GF people, and probably as rightly so, kind of took the ball and said, wait a second, we're making the engines. We know what these engines need. We don't need the oil companies telling us what we need. We know what we need. And so that's kind of how this interaction and interplay has gone on up to the GF5 level right now. Here's the ACEA levels. Like I said, this won't be on the quiz, right? Not a whole lot of useful information here. I mean, you might have seen these kinds of levels before. The A series of levels are a typical engine with your basic emissions equipment, and make some slight differentiations between these things. They've had some areas like, okay, we want extended drain intervals, so they had some requirements that would call for that. These classifications with the C in front of them, C1 through C5, mean that it's designed for use with a full load of catalysts and particulate filters and all that stuff to, it's catalyst compatible, so that when that's critical. And then the E series from ACAA, that's all heavy duty diesel stuff. Okay, so that's how the ACEA has things organized. All right, so those are the kind of the levels and how the quality is determined in the market. That determines what you see on the bottle of oil, what you see in the owner's manuals in terms of a requirement for oil of a given quality. There's also the need for the proper viscosity. Well, the viscosity and the viscosity levels, viscosity requirements are determined by a different organization, not the API. This is the SAE, the Society of Automotive Engineers. Okay? So the SAE just deals with how thick the stuff is. Okay? You can, and I mentioned this in classes before, you can have a jar of honey and get an SAE classification for it, right? It's not telling you anything about how good an oil it is, just how viscous it is, just how it resists flow. And once upon a time, when the first SAE classifications came out, it was very simple. Very simple. You measured the viscosity at 0 degrees Fahrenheit. That's your cold weather temp. And you measure it at about 210 degrees Fahrenheit. You know, so it's just below boiling. Okay, so that 210 kind of represents what the oil is like when it's in the engine, right? It's close to a heated up water jacket kind of temperature. And your zero F1, well, that's your cold weather one, like you're trying to start your car in Chicago or something like that. And then you go to a chart, and you say, okay, well, it falls within this certain range of a viscosity at a high temperature, then it's a 40. And if it fell over in this other range here in the cold temperatures, that was a 20W. Okay? All that W came about, meaning the W stands for winter. Okay? So it was the cold temperature measurement. So that's how the SAE came about. Over time, they've changed a little bit about that basic 2 measurement system. On the cold side now, instead of just putting it at 0, they found out, I mean, at the very least, you know, if the way they were measuring these things, even a decent oil, you take 2 or 3 hours just to measure one viscosity. Okay, well, okay, that's not working because we got this backlog of oils to measure in our lab. Well, they came up with 2 different systems. One of them, which mimics or measures or indicates how the oil flows, with the objective as to how the oil flows towards the oil inlet in an oil pan when it's cold. So it's measuring that kind of flow. The other one measures how hard it would be to crank an engine that's filled with that oil. It's actually called the cold cranking viscosity. Okay, those are 2 different cold flow properties because that you could have one of them be real good and the other be real bad, and it would be a bad situation. So they just said, okay, we're going to make our W requirements have to meet both of these cold things. So they made the cold end a little more complex. On the high temperature end, they did something similar. They still have the same deal where you measure the viscosity at 100 degrees C, which is 210 F, and that's part of the picture. And then they also introduced this idea of measuring high temperature, high shear viscosity. Okay? And the best way to imagine that is what's going on inside a cylinder, which has a thin coat of oil on the wall, as that piston and ring are slamming up and down really, really fast, right? You've got high temperatures because you've got combustion going on right there, so that's high temperature. You've got high shear because you have this rapid shearing motion going on. And your oil behaves a little bit different, or can behave a little bit differently under those conditions than it does just flowing through a regular viscometer at 100 degrees C. Okay, so the high temperature, high shear is supposed to represent exactly what's going on in some of these really tough circumstances in an engine. And so they started having minimum amounts that you got to be at least this much under high temperature, high shear conditions in order to get the kind of internal engine protection that you might really want. All right, so the high temperature, high shear thing will come up a little bit later as well when we talk about some of the new classifications on this stuff. All right. Okay, so coming up next, we're going to talk a little bit about a couple of the upcoming trends with passenger car motor oil, or current trends, upcoming things. So the first will be newer viscosity grades. Maybe you've seen this, maybe you've heard of it, maybe you hadn't. Some of these things have been in the dealership, for instance, and haven't been off warranty and out into the market in terms of people needing this oil. But has anybody seen 0W16 oil? Yeah, 0W20, as everybody thinks about, is a pretty thin oil now. The next grade you're going to see is 0W16. Honda has actually had this in the market for a few years, and some of these cars are going to be coming off of Honda warranty and Honda service packages so that they're more common in the market. And so our suppliers are now formulating 0W16 oils for the market. Okay? That's a trend. There's also a 0W12. Okay, there's a category for 0W12 oils. And, you know, why stop there? There's a 0W8. Okay? This is being used by Honda. These vehicles are in Japan. At least last I heard, they were for sale in Japan. They haven't been imported yet. Do you know how thick a 0W8 oil is? Okay. 0W8 oil is of the same viscosity as number 4 fuel oil. Now, diesel fuel is number 2 fuel oil, so it's a little bit heavier than diesel fuel, but not much. All right? Think of that, not much heavier than diesel fuel, and that's a engine oil protecting an engine. Pretty amazing stuff. And of course, yeah, driven by fuel economy and emissions. All right, so that's our trend in viscosity. Another trend, another buzz term, or another thing to be aware of is this concept of low speed pre-ignition, LSPI. Okay? LSPI is something that has shown up is known about actually, I'd say it didn't just show up, it's kind of been known about for a little while in turbocharged gasoline direct injection engines. Okay? So these are kind of extreme conditions. Okay? It's turbocharged, it's direct inject, but more and more engines are using this design because you can get a pretty good horsepower pop out of your same engine by turbocharging it and using direct injection. And so Tim managed to find us a very nice graphic on how this is working, or on how the direct injection works. As those of you who have enough gray would remember, there was a time when your fuel-air mixture would get mixed up in a carburetor up here. So you'd have air-fuel that came into the intake. All right, and then carburetors were replaced by throttle body injection for a year or two, where, again, up here, you were injecting fuel into the airstream, which would come on down. A vast improvement on throttle body injection was port fuel injection. So here in the intake port, you'd have an injector, up ahead of the valve that was injecting your air-fuel mixture, and the air-fuel mixture going in. And so the next thing is the direct injection, right? Our injector, like a diesel engine, is shooting directly into the combustion chamber. Okay? All right? So that's, again, gains in horsepower, improvements in emissions, but it makes life a lot tougher on a number of factors in the engine. And one of them has to do with this LSPI. It's called low speed because the RPM range is not up when you're revving this thing. Okay, everybody's had engine knock and ping that you get at high RPMs. This is showing up at 1200 to 2700 RPM. That's where it gets the term low speed, and it's said to be a more violent knock than your typical pinging, than the usual pinging that you get. And as you know, regular pinging is pretty bad, can do damage. This was doing damage faster than even regular pinging did, the LSPI stuff. So far, all the research, there was a lot of research done as to figure out the why. It looks like it's triggered by deposits and or oil droplets remaining in the combustion chamber. Okay? So once they determined that, they worked with reformulating oils and found out they could formulate oils that would get rid of LSPI. Okay, so that some oils would cause it, some oils wouldn't. And the engine oil, obviously you're an OEM, you're making these engines, putting them out on the market, and you got warranties to worry about. This LSPI stuff would be pretty important. Yes?
Now, this is something that doesn't traditionally affect a port injection.
Correct. Yeah.
What about some of the motors on the market, like the Subaru and the Toyota Flat 4s, where they have direct and port injection at the same time?
Well, and it also seems to be under the extremities of turbocharging, under the real high pressures. Yeah, yeah. So when SN Plus came along, this additional boost to SN, it was all driven by this LSPI. Okay, the OEMs, again, working through that ILSAC organization, said, wait a second, you guys are moving way too slow at getting us a better oil. We need to make an improvement now. We need something now. We got these engines out there now. And so they really, I would say, forced through. I don't sit on any committees or anything like that, so I don't really know what went on, but there was lots of slow motion weeping and gnashing of teeth to get the SN Plus pushed through so they could get some changes made to the oils on their engines. But that's where the plus comes from, and this SN Plus was driven by this LSPI phenomena. Okay, and then the third thing I wanted to talk about in engine oil trends is the next engine oil category. Next classification, you saw, remember or you may not remember my list from before, stopped at GF5. Well, next up is GF6. Poor old GF6. GF6 was first proposed in 2011. Does anybody here remember 2011? Joe, were you born in 2011? Just kidding. So it was first proposed in 2011. It was supposed to be done in 2015. Targeted for completion in 2015. Does anybody remember 2015? Currently expected in 2020. Okay, this is all the slow committee stuff going on within the API and the ILSAC group and that kind of stuff. It just passed another hurdle here recently. There was real concern that they had only so many test engines and test engine parts for the new GF6, and suddenly the ACEA decided they wanted to use that same test in their new classification. Well, that was going to take all the test engines and test parts that had already been accounted for in the US, and they were going to end up selling them to Europe. And all kinds of insanity goes on with this stuff, folks. But they somehow resolved that with these test stand parts. So that was the big hurdle that was passed just in the past few weeks. But originally, all part of this was supposed to address LSPI, right? That was one of the driving forces behind having this GF6, and that's one of the reasons the OEM says, look, you people are screwing around with this stuff. We're going to force through this SN Plus, at least to get that protection in the oil. So the OEMs couldn't wait, covered it with SN Plus. Other things that the new classification, again coming up in 2020, is designed to address include timing chain wear, okay, which has shown up in a few places, sludge control, more deposit control. That seems to be a thing with almost every new classification, is better deposit control and better sludge control. And if you guys have been if you've worked on engines for a long time and torn them apart, over a few decades, you can see the improvement. No question about that. And then also some other changes for fuel economy are built into the GF6 specification. All right, so that's rapidly coming here in 2020. All right. Do we have questions? This is the first chunk of stuff here. I want to stop and see if anybody's got any questions about our passenger car oil stuff we've been talking about here. Yes, Ernie.
Russ, can you explain a little bit about the cost of doing a test engine or passing
Oh, yeah, yeah. Ernie asked me to elaborate a little bit on the costs involved in passing some of these tests and how they're done. And this is one of these, okay, I'll try not to spend too much time on it because one can digress. But when they do these test stands and when they build they build very specific engines for these. And more importantly, it's specific parts. If you're trying to test bearing wear, I'll go for an example with bearing wear. You don't just go to SKF and get some bearings and put them in, or from whoever's making the bearings for that particular engine. The bearings are very specifically manufactured. They have to meet very specific standards. They're very carefully weighed and designed, and usually they're done on a specific run, so they're serial numbered. And so some of those bearings are used to create standards. And so when you get results, they're compared, okay, well, that was on the bearing lot 00167352 results. So these are very custom parts that are run. These engines are very custom engines. There's only a few places that have test stands or test engines to run these things. There's usually a long line of people waiting to do it. The cost of running these things is, the cheap ones are in the hundreds of thousands of dollars, or $100,000 to $200,000. If you have to do multiple runs, the cost is going up, up, up. A lot of time, the additive companies will get involved in absorbing the expense of doing the testing and then go out to the oil companies and saying, okay, our additive in your oil should give these results because we ran these tests in your oil, for instance. And it's pretty complex. It does run very slow, and I think Ernie's point he was trying to get at, very expensive to run this stuff. Very expensive. So you can't do these tests willy-nilly. It's a lot different than taking your sample down to lab 1 and having them run them through the spectro machine. Any other questions on passenger car oils? Because our next topic, we're going to talk very briefly about light-duty diesel. And what that means, light-duty diesels are something that you may be servicing as well right now. We've had other sessions. A couple months ago, we had a session on heavy-duty diesel. So we're going to be repeating just a little bit of that here. I apologize for anybody who was in that session. The API, much like with engine oils, car engine oils, also do truck engine oils. Okay? Now, in this case, they work a lot closer with the truck OEMs. So the truck OEMs haven't gotten into the same kind of fight that the passenger car OEMs have with the API. Right? They're working a lot closer together. As you can see, there's this march through time of improvements, starting with CA and CB, and the occasional nod to the two-cycle engines. Okay, not a lot of two-cycle diesel engines left in the first world anymore, but those were requirements that were designed in those years for two-cycle engines. Everything else has marched their way up to CJ4, is what we show on this chart. You notice the engine oils all start with S in the API. That's because they're all spark ignited gas engines. C series are compression ignited for diesel engines. 2006 was the CJ4 specifications, but at the end of 2016, API released 2 new classifications. Okay, the 2 new classifications were CK4 and FA4. All right, so that's what we're at, where we're at currently. CK4 and FA4. CK4 is a continuation of, I think I may have that on the next slide. Here we go. I'll just summarize these. Okay, both are 4-stroke engine oils. Both of them have improvements over CJ4, right? They're continuing that march of improvements. But the 2 are uniquely different products. Okay, nobody takes their CK4 oil and just slaps a different label on it. You can't do that. And here's why. Here's kind of a comparison. Both of them were designed, again, I said better than CJ4, and one of the targets the OEMs had on that was extending drain intervals. So both of them are real good at extending drain intervals even further. okay, high quality oils. The first difference we see up here is in the primary viscosity grades. Your CK4 is your heritage 15W40 stuff, your typical, your usual truck oil, available in 15W40. FA4 is going to feature lower viscosity grades, 530, 1030. The FA4 specification explicitly prohibits 15W40. You can't have a 15W40 meeting FA4. The next thing, different note, is this high temperature, high shear viscosity, right? This is the stuff that was going on at the piston walls that I mentioned, okay? CK4 requires at least 3.7 centipoise, okay? So it's got to be at least at a certain level, okay? FA4 falls between 2.9 and 3.2, okay? It's got a little bracket somewhere much lower, okay? Definitely designed to be a thinner oil, okay? Thinner in general conditions, thinner under high temperature, high shear. The whole design, the whole impetus behind that, the whole idea is this. The FA4 will give you somewhere between 2 and 3% fuel savings over CK4. All right? Now, if you're driving your Dodge Ram around, you may not notice the 2 or 3%, or it may not bother you much. But if you're night transportation, okay, and you've got tons of trucks on the road all the time, that 2 and 3% fuel savings is going to add up. So those were the kinds of driving forces that led to the mileage improvements called for in FA4. That and the fact that a vehicle getting 3% more miles per gallon fleet-wide across the U.S., okay, is emitting that much less in terms of pollutants. And again, on a vehicle-by-vehicle basis, you may not be able to notice it, but in an overall basis, over millions of vehicles, it starts to add up. So those were the driving factors between having FA4 as an engine oil. And again, it's on the heavy-duty side, but it's working its way to the light-duty truck side. And here's the important thing to note about CK4 and FA4 oils. Our CK4 oil, right, backwards compatible. You can use CK4 where you used CJ4 or CI4 or CH4, anywhere on down the ladder. Okay, CK4 is backwards compatible. FA4, not. All right, and it's this concern about this thinness coming into play. Is it going to be too thin for an engine that's 10 years old?
What year did they start demanding the FA?
That actually started in some engines in 2017, certain 2017 model years. Now, having said it's not backwards compatible, in some cases it is. It's been Detroit Diesel is a big advocate of these FA4 oils, and they will allow you to go back, I think, about half a dozen years in their engines and use it. And we know of some oil companies and some additive companies have done some fleet testing, even in mixed fleets with equipment going back 10 years old, where they're using an FA4 oil and they didn't have any engine problems. So you'll hear people talk about that, but by and large, it's not inherently backwards compatible. Okay, so here's why. Here's kind of the key takeaways I put up here for you guys. CK4 is part of an ongoing spec improvement, right? The march through time. FA4 is something that's brand new. All right, so when you see this in an owner's manual, you'll have a sense of that. Can't use the FA4 previously for CJ4, not without the known exceptions. The new FA4 category excludes 15W40. Couple notable exceptions otherwise to note. Ford 6.7 liter engines. When FA4 and CK4 came out, right at the end of 2016, Ford kind of jumped up and down and screamed and yelled and says, we've got these 6.7 liter engines that are exhibiting valve wear. Not only on the FA4, the light stuff, they're exhibiting valve wear on the new CK4 specification, which was supposed to be better going backwards. All right, so they wanted certain additives at certain levels in their oils. So Ford did go about granting some exceptions. A supplier, our suppliers, for instance, could go to Ford and have them test it against this particular Ford spec, a valve train wear test. If it passed, then it was okay to use that CK4 oil. So we sell Phillips Gardol 15W40 as a CK4 oil. That was one of the first oils that Ford approved on their list of okay to use CK4s. All right, so keep your eyes open for the Ford 6.7 liter engine. Ironically enough, on the light duty side, within the past couple of months or so, Ford came out with a bulletin announcement that they're going to allow or want or specify FA4 oils, the light stuff, for use in their diesels that they're putting in their F-150s. Now, I don't know which diesel engines those are, but the note was that Ford's going to be approving the use of FA4 in the diesel engines going into the F-150 pickup trucks. The bottom line, pay a close attention to what the OEM of the light-duty diesel engine says, and be aware that there are two new modern oils out there. All right? Okay, any questions about this light-duty diesel engine thing that I've been talking about in this new service oil classification? All right, because we will now spend a little bit of time with automatic transmission fluids, kind of an automatic transmission fluid update. We're going to cover cover in three main topics. Some transmission designs. You guys may know this, you may not. You may know a lot more about this than I do. Go over a little bit of the automatic transmission fluid timeline and history, and talk about that, and then spend some time talking about what ATF is, what it's made of, what kind of properties it has, and what's important to look for. Okay, so we're going to talk a little bit about automatic transmission design, and first we're going to go back to what I call the traditional design, the regular, the typical old school design. Traditional automatic transmission fluid has a torque converter, right? Torque converter is a fluid clutch that kind of allows things to engage and disengage without stalling. It's got a control system, a valve body. It's literally a little hydraulic system underneath there that's opening and closing some valves and causing actuators to move, that allows plates to shift and bands to lock up and gears to shift. So that's the control valve system. It's got a planetary gear set, or planetary gear sets would probably be better. Several of these things. That's how we're getting our power transfer, and usually they're designed the old school, the typical. For years, things were 3 speeds or 4 speeds. So this was a typical system for a long time. Then there was a little bit of a jump in technology. These later developments first included a move to transaxles. Okay, with a transaxle, now you had the transmission. You had a laterally located engine and a transmission mated to it. You no longer had a differential, hypoid gears, positrack kind of stuff going on. Instead, now you had half shafts and constant velocity joints, right? So that was a big change in the move to transaxles. We've seen more speeds. For a long time, 3 speeds and 4 speeds were the norm. I think I read recently that Jeep's got a 9-speed. I up there? Yeah, so marching our way through more and more speeds. Um, and another phenomena was the lock-up torque converters. The torque converters, again, it's a nice fluid clutch, but there was still some slippage. And in the pursuit of higher mileage, they've designed systems that at highway speeds, you're not relying on the fluid clutch. There's actually a physical made up with your torque converter, so you can improve your highway mileage by doing that. So those were some of the improvements over time on this typical or traditional design. Okay, so it's not that these designs are obsolete. Lots of the stuff out there, right? No question about that. But a newer design, something that's been growing in popularity, and it wouldn't surprise me to see it grow further, has to do with dual clutch transmissions, DCTs. Dual clutch transmissions are also known sometimes as automated manual transmissions or paddle shifts. Okay, dual clutch transmissions do not have the liquid clutch type torque converter. All right, so you've gotten rid of the liquid clutch slippage altogether in your shifting. You have a set of mechanical shifting going on. Both the computer and the control system are clutching as well as shifting the gears. And you can do this by setting this thing up with two shafts. Makes it easier for the engineering. All right. And within a dual clutch transmission, you have some special requirements on your transmission fluid, or I should say some additional requirements on a transmission fluid. It's got to be very consistent. You can't have it varying in viscosity, for instance, by a whole lot. And it's got a lot of work to do in there. It's got a lot of gears to lubricate. And second, the frictional characteristics. Because now it is dealing with the frictional characteristics in the clutches. Frictional characteristics are even more critical than in a regular transmission fluid. Okay, so these are often specialty. The lubricants involved in DCTs are often special part numbers, which if you've dealt with these, you probably already know that. Okay, so DCTs is one of the newer technologies to pay attention to in the world of transmissions. The second one, in terms of newer technologies, is the continuously variable transmission, or CVT. Okay, a CVT involves no clutches whatsoever, and by varying the shape of those pulleys, which are actually kind of cone-shaped in there, you're causing different ratios for that belt to go back and forth. Okay, so you've got this belt between two adjustable cone-shaped pulleys that are changing your drive ratio and your output ratio. You get very seamless shifting. There are a great many efficiencies to be gained by that, right? By doing that sort of thing. So we say that there's no shifting of gears. Frequently in smaller vehicles, that's certainly where they started at, because this is still a design that's not designed to carry 700 Mopar horses on it. Okay, the initial vehicle, if my memory is right, the initial vehicle in the U.S. that came with the CVT was the Subaru Justy. Anybody remember that? And if I'm not mistaken, the Justy was a 3-cylinder, and it was not a highly powered vehicle, at least. But the vehicles have been, the CVTs have been improving, and the vehicles they've been putting them in are larger and larger vehicles. There's also lots of metal-to-metal contact that goes on with this. There's a lot of metal moving parts in this. And when we talk about CVT fluid, I'll mention this again. But this is a much different scenario than what's in a typical transmission. All right, so that's the kind of the technology in review. I want to spend a little bit of time talking about historical and current transmission fluids. Okay, and to simplify my little graphic here, in my discussion, I've kind of focused on the stuff from Ford and GM, but other companies have starting in later, in the past decade and a half, got into their own transmission fluid designs and levels. Once upon a time, back in the day, people who, other smaller OEMs and foreign OEMs would adopt whatever the current GM ATF was, or the Ford ATF was, and used that in their transmissions. But as transmissions have become more complex, they said, oh, we got our own requirement in this transmission. So the real old school stuff back in the day, GM Type A suffix A. I still get phone calls, people calling in, hey, I need some of that Type A fluid. You got any of that? You know, well, nobody's really had any of that for a long time, but we can take care of something like that. Coming into the 60s, GM developed a fluid called Dexron. About the same time, Ford introduced a product called Type F. These were notably two different products. The GM transmissions, or hydromatics and all the stuff, the Dexrons, very smooth shifting. So the transmission fluid had an additive in there for smoothness, for slipperiness, when it would make the shifts, okay? The Ford transmission philosophy was different. Ford, for lack of a better term, wanted to make sure you knew that car had shifted. Right? I remember driving my grandfather to 74 LTD, you know, and we shifted gears, you knew it, all right? So Type F had no such slipperiness additive in it. So Type F and Dexron were mutually exclusive by their frictional characteristics. Next improvement from GM was in '73 when they came out with Dexron 2. Then in the 80s, Ford came out with Type CJ, and then shortly after that introduced Mercon. CJ, I don't know, I would call it a test product that came for just a couple of transmissions, but then they went widely to the Ford Mercon. And at this point, Ford kind of abandoned this idea of harsh shifts. Okay, so the frictional characteristics of Mercon were like the frictional characteristics of Dexron 2 and Dexron 3, which came up a few years later. And then a few years after that, Ford introduced Mercon 5. All right, so we're more common times. And then in 2004, Ford introduced some transmissions that took Mercon SP. And what was unique about Mercon SP was the viscosity was so much lower. Okay, all along viscosities of Dexron and Mercon were all here, and suddenly SP called for a lower viscosity transmission fluid. Why? Well, for your first guess would probably be right, that it improved mileage, improved efficiency. But not long after that, GM came up with Dexron 6. That was their low viscosity transmission fluid. A few years later, then Mercon LV. So Mercon LV and Dexron 6 continue to be the dominant low viscosity guys out in the market, at least certainly as far as the U.S. market. And it was in the 90s and such and on as when a lot of these other OEMs, Mitsubishi and Toyota and Honda, and everybody had their own products that they were coming up with as well, their own track. Okay. All right, so that's a little bit about the history and background of the different types of fluids that have been out there for transmission fluids. In terms of what we ask a automatic transmission fluid to do, I'm going to go over that a lot. And you remember that the transmission fluids are the same basic formula we had for engine oils. We got a base stock, we got additives. Our base stock in transmission fluids is more likely to be synthetic, or at least a synthetic blend. What we ask it to do in the kind of conditions we ask it to meet, and the very fact that people don't change their transmission fluid, really call for it to be a synthetic. It's a really good fit for what a synthetic has to offer, and that is relatively long life, right? So that's your base stock story. Your additives actually have several of the same additives that passenger car engine oils have. Some differences. They don't need anywhere near as much detergency, and they actually have more in terms of friction modification stuff to make for smooth shifts. And they've got red dye. Almost all of them have the red dye, right? So they do, but it does rely on additives a lot. So we ask our ATF to serve as a liquid clutch in the torque converter, right? So it kind of gets beat up there. It's a hydraulic fluid in the control system, Okay, it's part of the hydraulic, that shifting. It's a gear oil in the planetary gears, so it's got to keep the gears all lubricated. It's got to provide smooth shifting when you shift, right? The frictional characteristics. And it's got to last a long time, right? Or a real long time. Anybody seen some of the change intervals on more recent transmissions? I mean, they're like sealed for life. Or what these, some of these are presenting themselves with no interval. So these are what we're asking the oil to do, and the properties that we look for, or that we'll see in a transmission fluid to help us do all this stuff, first and foremost is the proper viscosity. Okay? We talked before that there was and I'll address this again, the operating viscosity. There are two different categories. There's the higher stuff, the old schooler stuff, and then there was the newer stuff, the low viscosity. So I'm going to talk about that in a later slide when we talk about products. There's oxidation stability and thermal stability, because the stuff really gets heated up and churned around. Has a chance to be blended with lots of hot air. Hot air starts to react, cause these reactions. That's what causes deposits and sludge and stuff like that. So it's got to fight that. And that's one of the benefits of it being a synthetic or even a semi-synthetic. Okay? We got to have a lot of wear protection. We're trying to protect these gears under some pretty harsh and occasionally shock-loaded kind of situations. Got to have a lot of load carrying capability. That also protects the gears. And you have to have the correct frictional characteristics to get the right shift, as well as have that frictional characteristic last a really, really long time. Okay, that's a separate formulation problem. You could put in an additive that has it shift great for the first 10,000 miles and then lousy for the next 90,000, but you don't want that. Okay, we also need to be able to make sure the stuff works when we go and put the car into drive when it's cold out. I had a 66 Dodge, had a little issue with that. It turns out if you change the transmission fluid on it, that helps. Change it, more than once every 100,000 miles. Of course, you want it to be non-corrosive, right? Not going to eat away any of your parts. Got to have some degree of dispersancy and detergency. The benefit there, it keeps deposits from turning into lacquers and coatings and stuff like that, varnishes on the inside of your transmission. Anti-foam properties, something you may not think about, but if your transmission oil is turning into foam, think about how well your control system's going to work, and the bad things that can happen if that foam is trying to lubricate planetary gears. Right, so anti-foam is pretty important, and then seal compatibility is important. Seal compatibility is an issue that's been, I'm not going to call it solved, but if you had a car here that was built in the 60s or the 70s, did you have a spot on the driveway after 50,000 miles? That was not uncommon, and it had to do with your seals, both engine seals and but particularly transmission seals. Would have problems with shrinking or swelling or cracking or falling apart. The seal issues that had been of that era, again, I can't say they're 100% gone, but they're much better these days. All right, so those are the kind of the properties we see in a well-formulated transmission fluid. I mentioned before I was going to talk a little bit about the viscosities. Okay, the high viscosity products. Okay, traditional older ATFs are what we call the high viscosity. Now, when I say high and low viscosity, I don't want you to get the idea that one's like water and one's like honey. Okay, they're not quite that different, but they are notably different. They are definitely notably different. The number of a high viscosity product is it's about 7.2 centistokes at 100 or higher. So 7.2, 7.5, 7.6. These are all typical things that a regular Dexron 3, Mercon, those kind of guys were in that range. Here's some examples of the things that in that viscosity regime. Low viscosity products, the newer stuff, and when I say newer, if you remember, newer started in 2004, so that's about only 15 years old. Low viscosity stuff is the newer ATFs. These are almost always synthetics. And one of the by the way, one of the reasons you can account for some of that is that, let's see if I can explain this on the fly without putting up a slide. The traditional old ones that were mineral oil, that were non-synthetic, would thin out fairly rapidly, because that's what mineral oils do. Synthetics don't thin out so quickly when you heat them up. Okay? So at operating temperatures, they're not quite, that difference in thickness is not as big as it was when they started. All right.
So you're starting with a lower viscosity.
So you're starting with lower viscosity. Yep, definitely. Definitely. All right. And of course, the drive behind this low viscosity transmission fluids was better mileage. And their numbers, these numbers are this 6.8 centistokes or lower. Some things at 6.6 and 6.5 we've seen, okay? And again, these are all viscosities at 100 C, which is 210 F. So the oil has been thinned out quite a bit by the time you measure that. But anyway, this is what the high viscosity and low viscosity difference is. Which, and examples of that are Mercon and Dex products. Which leads us into this thought and this idea of multi-vehicle ATF, right? We've all long had this Ford and GM types of transmission fluids, but you've got transmission fluid specs from lots of OEMs now, right? From the Toyotas and Hondas and Mitsubishis and Saab and everybody else out there. So it would be nice, it would be convenient for everybody to minimize inventory by having fewer transmission fluids, by consolidating down. So there has been two approaches to trying to do this and make more universal transmission fluids. And one is the two-product approach. You have a high viscosity product that meets your Dexron, your Mercon 5, your ATF plus 4, and certain Honda amounts, certain Honda requirements. And then you carry another product that's a low viscosity product, okay? So it meets the DW1 and the Mercon LV and the Dex 6. So you carry one product that'll meet the high viscosity stuff, and the other product that meets low viscosity stuff. And one of our suppliers, Phillips 66, does exactly this. They've got two different multi-vehicle transmission fluids that meet those meet things designed that way. There it is. I was one slide behind. All right. The other approach, other than this two-product approach, is the single product approach. Okay? A single product approach to a two viscosity system. Okay? So that might lead you to think, and it led me to question when this first came out a couple of years ago, how can an ATF be two different viscosities at the same time? Right? You got some stuff that requires the high viscosity and some requires the low viscosity. How can you have one ATF that's going to make everybody happy, that's going to meet the specs of both of them? And yet people were talking about this. I got thinking about it. It's kind of like, how can you be two places at the same time?
Oh, I hate that part. Hey, that's us.
Bill,
We're back in San Dimas.
strange
Yeah,
things are
only
afoot
now
in
it's
the
not
Circle
now.
K.
Let's go find out.
69, dudes!
Look, dudes, we gotta go.
All right. Okay, it's not quite the same as being having two viscosities at the same time, but you get the point. Okay, what's going on with this? Well, how can an ATF be two viscosities at the same time? The answer is it can't. But the sub-answer is maybe it doesn't matter so much. maybe it's not as important as we think it is. So if you look at what's out there in terms of these single product universal ATFs, these things came out, a lot of it initiated by the additive companies. These people do a lot of research with transmissions and transmission fluids. So they went around to the oil companies saying, well, we think we can do this. We think we got something for you. It has kind of the implicit backing of GM in that when GM came out with DEX 6, they said you could use DEX 6 in anything that had used DEX 3. Okay? DEX 6 is a low viscosity. Okay? DEX 3 was a high. They said, it's okay to use. We all scratched our head and said, well, what is it? Because the DEX 3 stuff is well out of warranty. That's part of the thinking that people figured were going on. And that's true of almost all the other transmissions too. Everything that had really required a high viscosity transmission is out of warranty. Well, too, the additive companies doing the testing on this did a lot of fleet testing. Did a lot of testing in older vehicles. Lots of field test miles. And they got these things to work. Okay? They get, your transmission is not falling apart just from using a LV oil. Part of it probably having to do with its synthetic. And the other part, and I think this is one of the things that GM might have used in their thinking, is that the anti-wear additives in Dexron 6, the thin stuff, the anti-wear additives are so good, they're compensating for the loss of viscosity relative to Dexron 3. So that's, I didn't sit in any meetings on that. I don't know that for sure, but that's kind of what I'm thinking they did on that. Okay? Keep in mind that there are still some exceptions even to these universal rules. Certain OEM products, like the dual clutch stuff, these special part numbers probably aren't covered in any of universal transmission fluids, and CVT fluids. Again, such unique requirements, you'd really be hard pressed to get at least with, maybe someday someone will have an even more universal ATF that covers it all, but definitely not any CVTs. Well, I already said not any, and that would be a lie, because there are some low power rubber-based CVTs that can use certain regular transmission fluids, but those are kind of rare. All right, and that does lead me to talk about CVT fluids real briefly. CVT fluids, I mentioned, started in small vehicles. Now Toyota Camrys can come with CVTs in them. This is sold generally as a standalone product, so they're not trying to make it meet anything else other than be a CVT fluid, although they do have it meet CVT requirements from a number of different OEMs. Okay, I know of none that aren't full synthetic. There may be some out there, but the severity of the duty on these things really calls for a synthetic. Very unique frictional characteristics going on here. You want to actually enhance metal-to-metal grabbing. Okay? You want that to happen, so that's completely the opposite of typical ATF. Largely because you've got a steel belt going in those steel pulleys. So you don't want slipping going on at that point. You want stuff to grab. And yet you've got other areas that are clutch materials, paper materials, that you want to have good smoothness going on. So you have to reduce one kind of friction while you enhance another kind of friction in these things. So it's a pretty unique set of circumstances there. And in addition, you're using, instead of the anti-wear additives that are loaded up in a typical transmission fluid, in a CVT fluid, you use EP additives. Okay? I won't take you down that path at this point, but in terms of preventing wear, this is the high school football team. This is a pro team. Okay? There's definitely different aggressiveness in how well it protects metal from wear. Very important in CVTs. Okay? And in addition, at least the CVT people had the foresight to not dye it red. You'll see it dyed colors, but all the ones I've seen At least they weren't red, so you don't have a chance to confuse that with your red transmission fluid. All right, guys, any questions about transmission fluids? We covered those. All right, well, that concludes our today's presentation. Oh, you got a question? Yeah.
So when is Versatrans?
Okay, the question is, what is Versatrans? And Versatrans is a product from Phillips 66. Phillips has two Versatranses. There's Versatrans and Versatrans LV. So the Versatrans is their higher viscosity multi-vehicle ATF. Versatrans LV is the lower viscosity ATF. All right? Yes, sir.
You said the new transmission fluid is not red. What colors have you seen?
Okay. And if you didn't hear that, the new transmission fluid are for CVTs only, not red. I've seen blue, and a purple, and I think a green. All right. Yes, sir. Oh, okay. Yeah, the question is, I've seen people use transmission fluid in power steering fluid, and is that legit? And it's really interesting. Well, not really interesting. Only interesting if you're a lube geek like me. Back in the day, back in the day, the old Dexron 2 days. Yeah, that's exactly what you did. Starting probably in the 70s or 80s, the pressures in power steering systems went up, and it was no longer providing enough protection. So they had to formulate and sell a different power steering fluid with better anti-wear characteristics in it. But recently, with the improvement in ATFs, I've seen requirements now or statements and positions where you can now use like Dexron 6 as a power steering fluid. Still go by what the manual says, but the quality on some of these later generation ATFs is such that it would provide that kind of protection that the old power steering fluids used to. All right? Okay, anything else? I want to thank you all for your attention, and look forward to seeing you again at another one of our presentations.
Thank you, Rob.